Hello viewers, today let us try to complete this lesson. So the last part of this lesson is mole concept. I already informed you, and today we'll try to complete this lesson. So now let's start. Before we give the definition of mole and mole concept, first we got to know this one. We can discuss along with question. What is Avogadro's number, or you can call it Avogadro's constant set. Actually, this Avogadro number is a fixed number and is a very big number and is used to measure small particles. So you think like this: you take 1 mole of C12 atom and measure how many C12 atoms are present in 1 gram molecule of C12 atom. Then experimentally it is found that in 1 gram molecule of C12 atom there are 6.022 to 10 to the power 23 number of C12 atoms. So this fixed number, it is called Avogadro number or Avogadro constant. So simply you can write like this: you can write Na as a symbol for Avogadro number or Avogadro constant. The number of C12 atoms present in 1 gram atom of C12 is defined as Avogadro's number, Na, and its experimental value is 6.022 into 10 to the power 23. That means Avogadro number or Avogadro constant is equal to 6.022 into 10 to the power 23. So this number is called Avogadro constant or Avogadro number. So you understand, you take 1 gram atom of C12 atom and measure it, the number of C12 atoms present in that 1 gram of C12. Experimentally it is found that there are 6.022 to 10 to the power 23 number of C12 atoms in 1 gram atomic mass of C12. That fixed number is called Avogadro number or Avogadro constant. So simply you can write Avogadro number is equal to 6.022 into 10 to the power 23. It's a very important number. You just get it by heart. And since we know the definition of Avogadro number or Avogadro constant, then we can come to mole. Let us see what is mole. This also let us discuss along with question. What is a mole? like this. When we say 1 dozen, that it means the number 12. And when I say 1 decade, it represents the number 10. And when I say 1 score, it represents the number 20. And when I say 1 gross, it represents 144, this number. So these are the names of some particular numbers. When we say dozen, it means 12. When I say decade, it means 10. When I say score, it means 20. When I say gross, it means 144. So these are some names of some particular numbers. Similarly, when I say 1 mole, it represents 6.022 into 10 to the power 23. So simply you can think like this. A mole is nothing but it's a name of a big number. And what is that big number? This big number is nothing but it is Avogadro number or Avogadro constant. You can use the symbol NA stand for Avogadro number or Avogadro constants. So mole is also something like this dozen, decade, score, gross, century, etc. So whenever I say dozen, it always means 12. Like that when I say 1 mole, it always represents this number, 6.022 to the 10 to the power 23. And from where we got this number? We got it from Avogadro constants or Avogadro number. That means Avogadro constant 6.022 to the 10 to the power 23 is also, you can call it 1 mole. So this is the meaning of 1 mole. So how will you give the definition of 1 mole? The definition, you can make a slight change here. 1 mole. The fixed number of atoms or molecules present in 1 gram atom. You can write like this, or 1 gram molecule. The fixed number of atoms or molecules present in 1 gram atom. If the substance that we use is, if it is in the form of atomic state, then we can use gram atom or gram atomic mass. And if the substance we use is in the form of molecule, then we are going to use gram molecular mass, GMM. But we know that that number is fixed. That is 6.022 to the 10 to the power 23. So that number is called mole. So here we write like this: the fixed number of atoms or molecules present in 1 gram atom or gram molecule of any substance is called a mole. And it is equal to Avogadro's number, Na, equal to 6.022 into 10 to the power 23. Like this, you can write the definition. So now the definition of 1 mole, it is written here. Let us see once again. The fixed number of atoms or molecules present in 1 gram atom, GAM means gram atomic mass, gram atom cell, or 1 gram molecule, GMM, gram molecular mass of any substance is called a mole, and it is equal to Avogadro number Na, 6.022 to the 10 to the power 23. Therefore, you can write 1 mole like this, 6.022 into 10 to the power 23 is also equal to Avogadro number. So if you know Avogadro number, then it is almost same in knowing mole. Mole and Avogadro number represents the same number, 6.022 into 10 to the power 23, this fixed number. So this is the definition for mole. So we finished writing the definition of Avogadro number or Avogadro constant, and we finished the definition of mole. And now let us come to mole concept. This is the definition of mole. But now we are going to discuss what is meant by mole concept. There is a concept, there is an idea regarding this mole. And that idea or that concept is called mole concept. And now let us see in detail what is this mole concept. Okay, let's graph. You can take 1 mole of any substance. So when we say 1 mole of a substance, then if you want to find out the number of substance or number of particles contained in that 1 mole of the substance, then it is equal to, you can write like this, 6.022 into 10 to the power 23 particles. It shows that suppose you have 1 mole of a chemical substance and you want to know how many particles are there in that 1 mole of substance, then the number of particles present in that 1 mole of substance should be 6.022 into 10 to the power 23 number of particles. If the particle is atom, then this represents the number of atoms, and if the particle is in the form of molecule, then this number represents the number of molecules. That means particles can be of atom or particles can be of molecule, but the number remains same, 6.022 into 10 to the power 23. So now 1 mole is equal to this much number of particles. This we call it expression of moles in terms of number of particles. And here you can write in terms of particles. That means when you want to convert that 1 mole of that substance in terms of number of particles, then the number of particles should be this much. This is given by this mole concept. And let us see another one. You take 1 mole of any substance and you think like this, that substance is in the form of gas, not solid, not liquid, but it is in the form of gas. And at that time, you would like to know how many liters of that gas make this 1 mole. Or in 1 mole of any gas, how many liters of gas is present. We like to know it. So this much amount of gas is present, 22.4 liter. You can write like this at NTP. But here we have one condition. When you want to find out the number of liters of that gas at normal temperature and pressure, NTP means normal temperature and pressure, then in that particular gas, and there is also only 1 mole, when you convert it into liters, its volume should be 22.4 liters. Whatsoever the gas may be, it may be oxygen gas, hydrogen gas, carbon dioxide gas, nitrogen gas, etc. Any gas, its volume remains the same, 22.4 liters. But the condition is that at normal temperature and pressure. N stand for normal, T stand for temperature, P stand for pressure. Here, I'll write and stand for normal. Or sometimes you can call it standard value. STP also you can call it. And T stand for normal temperature. Normal temperature is 273 Kelvin. Kelvin is also unit for measuring temperature. So in terms of Kelvin, normal temperature means 273 Kelvin. And then here P stand for normal pressure. Normal pressure in this case it is equal to 1 atmosphere. You can write in short like this. So when you want to change 1 mole of any gaseous substance into liter, then at normal temperature and pressure, you will get 22.4 liters in every mole of any gaseous substance. So this is also another information conveyed by mole concept. And now let us come to the mass. Sometimes we would like to know 1 mole of any chemical substance in terms of grams. That means when you want to convert 1 mole of any substance into number of grams, then how many grams are you going to get? Then it is like this. You can divide it into 2 parts. Here I will write like this. If the given chemical substance is in a form of atomic state, then 1 mole of that chemical substance, when you change into gram, then it is equal to 1 gram atomic mass. Or simply you can write gram atomic mass. Gram atomic mass means 1 gram atomic mass, if it is in a state of atom. And if the given substance is in a form of molecule, then 1 mole of that substance, when you convert into grams, it is equal to 1 gram molecular mass. In short, you can write GMM. Like this. So this is the first information and second information, and this is the third information. In the third information, it is nothing but it is an information to convert 1 mole of any substance into grams. So you can write here in terms of grams. For converting 1 mole of that substance in terms of grams. Grams means mass. All together, all these things, this is known as mole concept. You can write here mole concept. Then what is meant by this mole concept? Mole concept is a concept which correlates the number of moles and the number of particles and the number of liters and number of grams. It may be gram atomic mass or gram molecular mass. It depends on the nature of the substance you take. So this mole concept correlates these 4 things. 1, 2, 3, 4. These 2 same, but we divide it into 2 sections because sometimes the substance may be in atomic state and sometimes the substance may be in molecular state. If it is molecular state, then the mass in grams is equal to 1 gram molecular mass. And if the substance is in atomic state, then the mass of 1 mole of that substance in terms of grams, it is equal to 1 gram atomic mass. So this relation is called mole concept. And what mole concept tells us is, it tells 1 mole of any substance, when we convert into number of particles, then number of particles will be 6.022 into 10 to the power 23. And if you want to convert 1 mole of that substance into liters, if it is in a gaseous state, then it should equal to 22.4 liters at normal temperature and pressure. And if you want to convert that 1 mole of substance into gram, its mass into grams, then it equals to 1 gram atomic mass. If the substance is in atomic state, or it is equal to 1 gram molecular mass if the substance is in a molecular state. This information or this idea or this concept is called mole concept. Let us say, for example, I'll write here. Now let us take 1 mole of sodium. Na is symbol for sodium. You can take any other substance, but for us, now let us take 1 mole of sodium. This 1 mole of sodium, if you want to convert into number of sodium atoms, then the number of sodium atoms will be 6.022 into 10 to the power 23 number of sodium atoms. If you want to convert into numbers of sodium atom, then number of sodium atom will be this much. Then it means this number. And if you want to convert 1 mole of sodium atom into grams, its mass into grams, then look, this is sodium atom, so you cannot go this side. You come this side. Then what you have to use? It is equal to gram atomic mass of sodium atom. Then you can write like this: gram atomic mass of sodium. Then how much it will be gram atomic mass of sodium? If you know atomic mass of sodium is 23, then its gram atomic mass of sodium should be 23 gram. That it means when you want to convert 1 mole of sodium into grams, then 23 grams of sodium should be there. So this is the idea. Like this, instead of atom, here you can put molecule also, no problem. Water molecule, copper sulfate molecule, sodium chloride molecule, or any other molecule. And if it is molecule, then you have come to decide. When you want to sense its mass into grams, you have to use this. That means you have to use its gram molecular mass. So do you understand this? So can you write? When someone asks you what is meant by mole concept, I'm telling you once again, mole concept is nothing but is a concept or idea which correlates the number of moles with the number of particles, with the number of liters, and its mass into grams. And that is equal to gram atomic mass if the substance is in the form of atomic state, and it is equal to its gram molecular mass if the substance is in the form of molecules. So this is called mole concept. Clear? Okay, anyway, let's work out one problem. Let me rough now. Now let us take one mole of H2O molecule. Let us take 1 mole of water molecule. Now I would like to sense this 1 mole of water molecule into number of water molecules. Then how many water molecules will be there? It should be 6.022 into 10 to the power 23 number of H2 molecules. According to the mole concept, when you want to convert 1 mole of water molecule into number of water molecules, then this much number of water molecules should be there. And when you want to sense it into grams, the mass of 1 mole of water into grams, then how will you find out? Since it is given in the form of molecule, then you have to take gram molecular mass of water. Then gram molecular mass of water is equal to how much? Could you tell me? Molecular mass of water is for hydrogen, for 2 hydrogen 2, for 1 oxygen atom 16 O, then altogether 18 U. 18 U is the atomic, molecular mass of water molecule. Then gram molecular mass of water molecule should be 18 gram. Like this. 1 mole of water molecule is equal to 6.022 to 10 by 23 number of water molecules. If you want to convert it into number of particles, molecules are particles. And the same 1 mole of water molecule, if you want to convert its mass into gram, then it is equal to gram molecular mass of water. But you know gram molecular mass of water is 18 gram. So 1 mole of water molecule is equal to 18 gram of water. Like this. If it is in a form molecule. But since here we do not necessary to find out its volume because water is in the state of liquid, not in the state of gas. If it is gas like chlorine, oxygen, hydrogen, nitrogen, etc., then you can convert it into liters. And at that case, it should be 22.4 liters at NTP. So like this. So now from this, you can make a conclusion. 1 mole of H2 molecule is equal to 6.022 into 10 to the power 23 number of H2 molecule is equal to 18 grams of water molecule. So this is the relation according to the mole concept. 1 mole of water molecule is equal to 6.022 into 10 by 23 number of water molecules is also equal to 18 gram of water molecules. This is mass in grams, and this is number of particles, and this first one is number of moles. Number of moles, number of particles, mass in gram, like this. It is given by the mole concept. So, can you write now the mole concept? You can be asked for any chemical compound, and you can be asked many numerical problems regarding this mole concept. So now, let us work out some numericals from this mole concept. Like this. How many water molecules are present in 1.5 moles of water? This is the question. How many water molecules are present in 1.5 moles of water? Number of moles is given, and we are asked to find out the number of water molecules. Number of water molecule means the number of particles. Particles here it means water molecule is a particle. So this can be found out very easily since we know the mole concept answer. You write like this. What are the given? Number of moles of water is equal to 1.5 moles. What is required? We have to find out the number of water molecules. Number of water molecules. Here, this water molecules represents particles. In 1.5 moles of water. Then how you do? Then you use your mole concept. You write like this: by mole concept. According to our mole concept, 1 mole of any substance is equal to 6.022 into 10 power 23 number of particles, if you want to sense into particles. But in this question, look, number of moles is given, number of particles is not given, and we are asked to find out the number of particles. But actually, mole concept is a relations between number of moles, number of particles, number of grams, and volume in terms of liters. 4 parts are there. Out of these 4 parts, this is necessary since it is given to us. This is also necessary because we are going to find it out, that it means number of moles and number of particles. The relationship between the number of moles and number of particles is necessary out of those 4 parts. So we are not going to write all the 4 parts. Instead, we are going to write like this: 1 mole of water molecule is equal to, when you want to sense into number of particles, then it is equal to Avogadro number 6.022 into 10 to the power 23 number of H2 molecule. Only in 1 mole of water molecule, this much number of water molecules is there. But in the question we are given 1.5 moles. Then you can find out very easily by using unitary method. Now you write 1.5 moles in 1.5 moles of water. Then how many water molecules should be there? If there are 6.022 to 10 to the power 23 number of water molecules only in 1 mole. So for 1.5 moles, this should be into 10 to the power 23 into 1.5 number of water molecules. Then simply you can multiply these 2 numbers like this: 6.022, 1.5, 10, 11, 30, 2, 2, 0, 6. 3, 3, 0, 9. 1, 2, 3, 4. 1, 2, 3, 4. Then it is equal to 9.033. We can drop the last 0, 10 to the power 23. Number of H2 molecules like this. This is very simple. Once you know the idea of mole concept, then you can calculate the number of particles. Sometimes you can find out the number of grams, and sometimes you can find out the number of moles, and sometimes you can find out the number of liters if you are asked to find out the volume of any gaseous substance. So this is one of the examples. And now let us see some more numericals. Let us take up some questions from your textbook, some numericals. Question number 17. How many atoms are there in 0.24 mole of oxygen. This is the question. Let us see. How many atoms are there in 0.24 mole of oxygen? Here, oxygen is not in atomic state, it is in molecular state. It is already given in your question. O2 means oxygen molecule. If it is oxygen atom, they should mention oxygen atom. Now let us make the answer. What is given in the question? Number of moles of oxygen molecule is given. Number of mole of oxygen molecule. O2 means oxygen molecule. If it is only O, then you can take it oxygen atom, but it is not oxygen atom, oxygen molecule. 0.24 mole. This is given. And what is X? Let us write required. Number of atoms of oxygen. Symbol is O only. Symbol for oxygen atom is only 1O. Symbol for oxygen molecule is O2. You see the difference. We are not asked to find out the number of molecules of oxygen molecule, but we are asked to find out the number of oxygen atoms. Even though we have to find out the number of oxygen molecules first. Once you have the number of molecules of oxygen, then you can find out the number of oxygen atoms. It's very simple. You know, in one molecule of oxygen, there are 2 atoms. So if you find out total number of oxygen molecules present in this much mole of oxygen molecule, then to change it into number of atoms, then you have to multiply by 2. Because one molecule of oxygen is made by 2 atoms of oxygen. So let us apply mole concept. By mole concept. This time let us write all 4 parts. 1 mole of O2. O2 means oxygen molecule is equal to 6.022 into 10 to the power 23 number of O2 is equal to 4 oxygen molecule. Its gram molecular mass is 16 into 2 is equal to 32. So you can write 32 gram. This 32 gram is gram molecular mass of O2. Since it is given in the form of molecule, so we are using gram molecular mass. 1 mole of any substance, when you convert it into grams, that is equal to gram molecular mass of the substance. So here the substance is O2. Gram molecular mass of oxygen is, there are 2 oxygen atoms for 1 oxygen, is 16 for 2, it should multiply by 2, then you get 2, 6 are 12, 2 1 is 2, and carry 1 and put it 32. 22.4 liter at NTP. So here I am showing all the parts, whether they may be necessary or not necessary. Number of moles. This is number of moles. And this is number of particles. And this is number of grams. And this is number of liter. I am showing the full picture of mole concept here, but that mole concept we apply to oxygen molecule. So I am writing here 1 mole of oxygen molecule is equal to 6.022 to 10 to the power 20 number of oxygen molecules is equal to 32 gram of oxygen molecule is also equal to 22.4 liter of oxygen molecule at NTP. Number of liters, number of grams, number of particles, number of mole. So the relations that correlate between number of mole, number of particles, number of grams, number of liters, that is called mole concept. But look, according to our questions, we do not need all these things. What do we need? We need this mole, because mole is already given. So I'll circle like this, and this is needed for us now. And then number of oxygen atoms are asked. For that we have to find out number of oxygen molecules. Then number of particles that it means. So we need this one also. But this one at present we do not need. We are not going to find out the mass in grams. And this also we do not need, because we are not going to find out the number of liters of oxygen gas. So these two parts not necessary. Only these two parts are necessary. So from these two parts, first you find out the number of water molecules. Therefore, you can write 1 mole of O2 is equal to 6.022 into 10 to the power 23 number of O2. Only these two parts. The other two parts are not necessary. Because of that, we leave it. And then, for us, we are given 0.24 mole. Therefore, for 0.24 mole of oxygen, how many oxygen molecules should be there? If you know the value of 1 mole, then you can find out the value of any number of moles. By how? By multiplying the value of 1. 6.022 into 10 to the power 23 into by 0.24. This must number of O2. O2 means oxygen molecule. Oxygen molecule. But in the question, we are asked to find out the number of atoms. Then lastly, you can do like this: 0.24 mole of O2 is equal to 6.022 into 10 to the power 23 into 0.24 into another 2. Why I am multiplying this number by 2? Because you know, in one molecule of oxygen there are 2 atoms of oxygen. So these are the numbers of molecules of oxygen molecule. So when you want to find out the number of atoms in this much number of molecules, then you have to multiply by 2, because 2 atoms of oxygen made 1 molecule. Because of that, I am multiplying by 2. Number of O. O means oxygen atom. Oxygen atom. Like this. Then you multiply how much you get. You can calculate working color. Here like this. You multiply this number, and this number. 6.022. First you multiply by 2, 4, 4, 0, 12. And then multiply by 0.2. 0.24. 4 4s are 16, 4 4 are 16, 17, 4 2s are 8, 4 1s are 4, 8, 8, 0, 4, 2, 6, 15, 8, 9, 10, 9, 8, 2. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Then you can write 2.89056 into 10 to the power 23 number of O. So this is your answer. Like this you have to work out. I think you understand how I work out the numerical problems. So anyway, for you also you can do the same thing that I did in the whiteboard a while ago, if you know the concept of this mole. So try to understand the mole concept.